Good. Welcome to our last class for this semester. I'll start by a question from Lisa. Minus x squared minus plus 4x minus 1 is 0. In the assignments, you are supposed to use the discriminant to check how many solutions, how many real solutions this kind of equation will have in case it's true. So the discriminant given any equation of the form x squared plus bx plus c is 0, we define the discriminant as b squared minus 4ac, this number. And we stated that depending on the sign of this number, you can tell how many solutions, or how many zeros an equation will have. If it is positive, you expect 2 real solutions. If it is 0, you expect 1 solution. Of course, it will be repeated. And if it is negative, there will be no real solution. No real solution. Or you will have complex roots. So when I say you should conclude, this is one of the, I expected you to tell me at least one of these 3 conclusions. So here, b is 4, so 4 squared minus 4, a is 1, c is negative 1, so that gives you 20, which is greater than 0, positive. So this equation, even without solving, we know we are expecting 2 solutions because of the sign of the discriminant. So this is what we are supposed to say, Lisa. Then we should say the solution. Say equation will have 2 roots or 2 distinct solutions. Is that okay? Is it clear for you now?
Yeah.
Good. Any more questions? Well, in case there's no more questions, we will try to see how you are supposed to answer such kinds of questions. I'll start with section A. The first problem you are asked that you should mark whether it is true or false, and you must justify. So the first one is this expression x squared minus x. The statement says this is a rational expression, in x, rational in x. What do you think? Is this a rational expression? So such a question, you're supposed to refer to the definition of rational expression. Okay, we define a rational expression as a fractional expression for which numerator and denominator are polynomials. Of course, this might be a fractional expression if I put this as a fraction divided by 1. But now the next thing you should check is that both the numerator and the denominator are polynomials. Of course, 1 is a constant polynomial, but is the numerator a polynomial? Is this x squared minus cosine x a polynomial in x? Hello?
No.
Why? Why not? What makes it not be a polynomial?
Because
The cosine, yes, the cosine. So it's not a polynomial because of this cosine. So here you will say false. You will say false and then say that this is not a rational expression. You don't have to give the definition. Okay?
Wait, so I have a question.
Yes.
So the way you in the question you have to show whether it's true or false, and then you justify. So by justification, you mean like we explain it's false because
Yes.
of
It's false. So yeah, it's false because x squared minus cosine x is not a polynomial. It's not a polynomial in x. And the problem is this guy, cosine of x. That is what makes it not to be a polynomial in x. Okay. Are we agreeing?
Yes.
Good. Second one, you have that this system 5x plus 5y is 5, and 20x plus 20y is 1. It says this system is solved by the ordered pair xy is 10, 6. So you're being told that this system is solved by the solutions x is 10 and y is 6. So in other words, you're being asked to test if these are zeros of this system. These two values for x and y will satisfy this equation. Someone said false. Why?
It's because by substituting the x values and y by the 10 and 6, it doesn't like correlate to the
Good.
equation given. Yeah.
You just test. You only need to test one. One is enough. So if you try 5, 10 plus 5, 6. Well, this gives you 50 plus 30. And of course, we know 80 is not equal to 5. So that system cannot be solved by this because it doesn't satisfy the first. You don't need to test this. Because for a solution or a zero of a system, all the equations satisfy. In case I tried and found it works for the first equation, I need to test the second one. Good. So that would be false. Then you're asked this sum from I is 1 to infinity over I is infinity. Is that a true statement or a false statement? Because the definition of sigma, so in this case, summation of I1 to infinity, some of the first few values will be like 1 plus 2 plus 3 plus 4. It goes on and on up to infinity. Is it true that this sum is going to be infinite? Hello?
yes.
Will this sum be infinite?
Yes.
Good. So if it's infinite, then it means the statement is true. The statement is true. This sum will be infinite. And then next we have that this set is a set P. 1, 2. Will you guys need this recording?
Yes.
Oh, okay.
You're recording already.
Okay, good. Okay, I was not recording. So is this set finite or infinite? We define the finite set. Finite sets. These are sets whose cardinality is finite. Cardinality is finite. And then infinite sets. Infinite sets are those ones with infinite many elements. Infinitely many elements. So looking at this set, is it a finite set or an infinite set?
Finite.
Finite because the cardinality is a finite number. That's 4 elements. So that's a finite set. So which means the statement is false. The statement is false because P has 4 elements, and 4 is a finite number. So this will be the justification. Statement is false because the set P has 4 elements, and 4 is a finite number.
Can you also say because the cardinality is finite instead of stating the number of elements?
Yes, yes. You can also say just say the cardinality is finite. That suffices. That's enough. And now the last one here is that this equation has at most one solution. We have x to the 100 plus 1 is 0. Has at most one solution. What do you guys think? Can you say about that statement? Or any ideas around it? X power 100 plus 1 is 0. You're being the statement said that this equation has at most one solution, which means this system has only one solution in case it will have. So it cannot have more than one solution. That is what the statement is saying. Is it true that this equation has at most one solution? Or rather, how many solutions will this system have in case it does?
Is it 2 solutions?
I don't know. I don't know if there are 2 or more than 2. You remember fundamental theorem of algebra? Fundamental theorem of algebra, where we said that any polynomial, because this is a polynomial with x, right? It's a polynomial of order 100. Any polynomial of the form a n plus all the way to all not z to the n. So if it's order n, it will have n solutions, some or all of which may be repeated. Here we have a polynomial of order 100. So we expect this to have at most 100 solutions. In fact, we will have 100 solutions for this. In the complex plane, of course. Because you'll want to solve x to the 100 is equal to minus 1. Then apply the de Moivre's theorem, it will give you 100 zeros for this system. So that statement is going false because we are expecting at most 100 solutions, not at most one solution. Any questions up to there? Good. Section B, we have the first one, we have 2 polynomials. So there's a p, which is ax plus bx squared. The polynomial q is ax cubed. A and b are real numbers. Find px times qx. So you're being asked to multiply these polynomials. Now for these other sections, there is no more true and false. You have to work it out and give your solution. So how do you multiply polynomials? Very easy. Just write the first polynomial, x plus bx squared. Then the last guy is ax cubed. Now what are we going to do? We're going to use all the elements in the first bracket. Use all these guys and then use them to multiply what's outside the bracket. Just usual expansion. So I will take ax multiplied by ax cubed plus bx squared multiplied by ax cubed. Well, so here I have a times a, that is a squared, x times x cubed is x to the 4. I'm using laws of exponents. So when you're multiplying, you just add the exponents and return the base. And then here we'll have b times a x to the 5. Where 5 is 2 plus 3. So that's your product. And you cannot simplify it more than this. Now we have these three sets.
Prof, excuse me.
Yes, go ahead.
But like in exam, in this section B, we only respond to 2 questions of the 4 questions.
Yes, you only choose 2 of the 4.
Okay.
Well, if you choose more than 2, then I will grade only 2.
Okay.
Yeah. So we have Kenya.
Excuse me?
Yes.
Have you posted that on the Blackboard? So I can simplify.
It's on the chat.
Oh, okay.
It's on the chat. Check on the chat.
We joined after you already posted, so we can't see it.
Oh, I can send it again. I can send it again. I just a moment. So this, that, and boom, there you go. Should be there. Are you able to see it? Hello?
Yes,
Yes.
we're able to see it.
Everyone should be seeing it. So, what is this? Okay. Kenya, Uganda. You're supposed to compute. There's no need of me writing all these things when you have. I've been asked to compute S intersection T union K. Okay, so because of this bracket, first of all, we compute S intersection T. How did we define intersection? Can someone remind us of the definition of intersection of sets? How do you find the intersection of sets? Or what does it mean for 2 sets to intersect?
Set of elements that are common.
Yeah, elements that belong to both sets at the same time. So S intersection T should be elements which belong to S and belong to T at the same time. So which are those elements for this case?
Ragak.
Yes. It's the only one. Then now you need to compute S intersect T union K. How about union? What's the union of 2 sets? Union of sets. So intersection belongs
Kenya,
to.
Uganda.
Yes, go ahead. Hello?
It's all the elements that
Kenya,
belong
Uganda.
to sets.
Elements that
Belong to both sets.
no, that's not union.
All elements in both sets.
No, that's not the definition of union.
It's
Okay,
the set of
Elements that can be in one or the other.
could be in one or
Or
even in both. But when you just say elements which belong to both, you're referring to intersection. And the reason for that is intersection is actually part of the union. It's contained in the union. So if you have, this is your set, maybe this is S, maybe this is T. Remember, this is the intersection, the one I've shaded. This is S intersect T. But the union is everything. So you can see S intersection T is contained in S union T. So to be in the union, I can belong to S, or I can belong to T, or I can belong to both of them, which means I'm in the intersection. So now the union, just put everyone together. So here we already have Ragak. Then now we need to bring everybody who is in K. And for K, we have Rwanda. We have that is your S intersection T, union K. Everybody will belong. So we have another K. We have K there. Okay, you might also be asked what's the cardinality of this set. Just count the number of elements in that set. And then we have the definition of a rational number. What's a rational number? Us to define a rational number and give an example. So remember we started by defining natural numbers, the counting numbers. Then we said that for us to do most stuff, we need to include the negatives. So we define integers, which contains the negatives. Then we went to rational numbers, because you have to be able to solve equations like 2x is equal to 1. You cannot solve this in natural numbers or in the integers. So the definition is that the set of natural numbers are numbers of the form a divided by b, such that b is not 0, a and b belong to the set of integers. Or say that a belongs to the natural numbers, b belongs to the this is the set of rational numbers. All numbers that can be expressed as fractions, basically. So many examples. I have one is a rational number, 0, 20 divided by 2 million. Okay. All those are rational numbers. Any number which you can write as a fraction is a rational number. So by default, natural numbers are rational. Integers are also rational because they are contained in the bigger set. And then we have factorize this guy. I'm going too fast to stop me because there's something you want to ask. Factorize this guy. Well, to factorize an expression simply means to write it as a product of expressions of lower order. So this is order 3. You are supposed to write this polynomial of order 3 as a product of polynomials of lower orders, so order 2 or 1, even constant. Now you need to remember this identity. A cubed plus B cubed is A plus B multiplied by A squared minus AB plus B squared. We proved this in class. So this is the identity you're expected to use. Now, of course, remember you can write 8 as 2 cubed, so you can write this as 2x cubed plus 1 cubed. 1 cubed is 1. Okay. So once I've written it in this form, then I let A play the role of 2x and 1 to play the role of B. Then I will just have, well, 8x cubed plus 1 will be. So then A plus B, I will have 2x
plus
1, and then 2x squared, okay, minus 2x times 1 plus 1 squared. So finally you have 2x plus 1 multiplied by x squared minus 2x plus 1. That should be the factorization. Okay. And you can always check. In future about such kind of problems, you can always check by expanding this to see if you get back to the initial formulation. Good, so that was so easy. Keep in mind this identity. Expand this expression, x plus 1, 2x minus y. Again, check everybody in the first bracket. Use it to multiply all those guys in the second bracket, and then combine or simplify. So we take x multiplied by 2x minus y plus 1 multiplied by 2x minus y. So now x times 2x, x squared, x times y, so we have minus xy, plus 1 times 2x, that's just 2x, then 1 times minus y is just minus y. So now it happens that we cannot simplify this any further. We don't have any common term, so we just leave it like that. 2x squared minus xy plus 2x minus y. Cool. Problem number 3. Problem number 3. We have root 75 plus root 48. You have been asked to combine these radicals. Combine the radicals. Now the trick here is to usually look for perfect squares. So look for a way of writing these numbers as some products of factors for which one of the factors is a perfect square. Perfect square, you know, numbers like 16, 4, 9, numbers which you can write as something else squared. For example, 9 is 3 squared, 16 is 4 squared, 4 is 2 squared. So that's what you're going to do here. Well, you could write 75 as 3 times 25, and you could write 48 as 16 times. Of course, this is not always straightforward. You might have to factorize this 75, prime factorization, before you're able to identify this. So you know 75, you start by 3, because 2 cannot divide it, so 3 is the next guy, 25, and 5, 5. Even this will still give me what I want, because when I have 5 squared, that's 25. I know that the root of 25 will be 5. And now after this, what you need to remember is this rule. The nth root of a product is a product of the nth roots. These are simply the laws of the exponents. So in this case, the square root of 3 times 25 should be square root of 3 times square root of 25. Oh no, 5 is 5, so this should be 5 times square root of 3. Then 16 times 3, this rule tells us that it should be square root of 16 times square root of 3. So this is going to be 4 times square root of 3. Now finally, do the addition. So root 75 plus root 48 should be 5 plus 4 3. And this gives you 5 plus 4, that must be 9. So this way we have combined these radicals into one and radical. So the trick here is to be able to write the radicals. So what is inside the root? Should be able to write them as factors for which one of the factors is a perfect square. You should factorize them, and one of the factors should be a perfect square. Then what's a linear equation? And give an example. Well, to define a linear equation, definition, remind you, a linear equation use anything in T is any equation equivalent one of the four AT plus B is equal to 0, where A and B are real numbers. This was our definition of a linear equation. Any equation which can be written in this form is a linear equation. So many examples that you can think of. 2x is equal to 4. That's a linear equation in x. 4s plus 2 is equal to 6. A linear equation in s. 10y minus 6 is equal to 4y plus 20. Linear equation in y. So this can be written in this form as, you can write this as 2x minus 4 is equal to 0. So x is your t, a is 2, and b is minus 4. Write this as 4 minus 4 is equal to 0. So what I did is to subtract 6 on both sides, say they're equivalent. And even this can also be written in this form. So any equation which can be written in this form, a and b real numbers, t your variable, dummy variable, that's what we call a linear equation. Essentially, all linear polynomials can give you linear equations. So you must ensure that the independent variable is of degree 1. Okay, if I change this to maybe t squared or t cubed, it ceases to be a linear equation. And now we have simplified by eliminating all the negative exponents. Okay, you must remember all the laws, they were about 10. We have j squared s to the minus 2 divided by k to the minus 4. All of this s to the minus 3. Well, for such kind of a problem, one single identity you need to remember is that a raised to minus n is 1 divided by a raised to n. With just this identity, you are able to do the job. This enough will do the job. Okay? Because when I have this, it means 1 over a to the minus n should be 1 divided by 1 over a to the n. That you get a to the n. So if there is anybody who has a negative exponent downstairs, take it up, change the sign. If there's anyone who has a negative sign upstairs, take it down and then change the sign. Well, so here we have, first, let's deal with what is inside the bracket. Okay, so we have j squared divided by, to change the sign of s from minus 2, we need to take it in the denominator. So we'll have s squared. I've used this law. A to the minus n is 1 over a to the n. My a is s, n is 2. And then k to the minus 4. I will take it upstairs, switching now this second law. I have here k to the 4. Outside raised to the minus 3. Again, the same law will help me here. So it's telling me that I take everybody. I need to find the inverse of this guy. Okay, so I want to write this as 1 divided by j squared a to the 4 divided by s squared cubed. I've changed the sign. So now finally, we'll have s squared divided by j squared k to the 4. Everything. You can leave your answer at this stage, or you can go ahead and raise the powers. S to the 6 divided by j to the 6 and k. So, and either of this is acceptable. Always remember this law, because all the other 10 laws that came up with come from this guy. There's a gas leaking. After S minutes, the number of service providers that inhale the gas is modeled by this function. How many have inhaled the gas after 9 minutes? So this is very easy. You just substitute. We need to compute n of 9. So remember, n of s has been given us 621 divided by 11 minus exponent minus 0.2 S. So when you have this after S minutes, now when you have 9 minutes, just substitute for S with 9. So n of 9 should be 621 divided by 11 minus exponent minus 0.2 and 9. So this is going to be 621 divided by 11 minus exponent negative 1.8. Use a calculator to compute this. Someone compute this, give us the value. What's this in the calculator? What did you get?
57.
7 point?
32.
32. 57.32. Now there was a similar question in the is that?
Niko poa kabisa, niko aje? Niko fiti.
Three two.
Well, whatever. So, but then, you know, this is number of people. You cannot say that there's a 0.5%, 0.3%. Okay, so you need to either truncate or round off, or whatever. So just say approximately. Seven people. I observed that in the assignment, most of you are just leaving your answers as decimal like this. Okay. Lastly, for this one, rationalize the denominator. 1 divided by 1 plus the root of 6. How do you rationalize?
You find the conjugate radical.
Yes, you find the conjugate radical. And what is the conjugate radical of what in the first place? The numerator, the denominator?
The denominator.
Good, the denominator. But if you are asked to rationalize the numerator, then you need to find the radical conjugate for the numerator. So what's the radical conjugate for this guy?
1 minus square root of 6.
1 minus square root of 6. Anyone with a different choice for radical conjugate? Another different choice? You also choose minus 1 plus square root of 6. You get the same. If we use this guy, we need to multiply each term by this guy. So multiply the numerator. So it's 1 times 1 minus 6. Then the 1 plus 6. Multiply the 1 minus 6. Okay. Numerator, it's very easy. Any number multiplied by 1 is that number itself. In the denominator, to save yourself from the discomfort of doing these expansions and adding, and you might even end up making mistakes because of these roots. Remember this identity, the difference of squares. A plus B times A minus B is A squared minus B squared. So in this case, let A be 1 and let B be root 6. So I have 1 plus root 6 times 1 minus root 6. Well, this identity tells me that I should be getting a squared. So a squared is just 1. Because 1 squared is 1. Okay? Minus b squared. B is root 6. So what is b squared? What's root 6 squared?
6.
6. So this should give you 1 minus root 6 divided by negative 5. Or you could give your answer as root 6 minus 1 divided by 5. That is if you choose this as the conjugate radical. How about someone who decides to choose the other one? The approach is the same. I will still take 1 fraction multiplied by the conjugate this time around, negative 1 plus root 6, negative 1, 6. Again, in the numerator, everything multiplied by 1 is that number itself. Stays. In the denominator, again, I want to use this identity. This identity which we have proven, so it will never let you down. Now, to do that, this is 1 plus root 6. You can write this as root 6 plus 1. Why? Addition is commutative. And this other side, we can write as root 6 minus 1. You have a minus 1 plus root 6 is the same as root 6 minus 1. Now, I need to use the identity that a plus b times a minus b is going to be a squared minus b squared. Choosing a to be root 6 and choosing b to be 1. So here we should have a squared minus b squared. Well, when a is root 6, of course, a squared will be 6. B squared is still 1. So here, a squared, I will have 6 minus 1. And then this simplifies as negative 1 plus root 6 divided by 5. And that should be the same as what you get on the other side. So it should be identical. This is 6 minus 1. This is also like 1 plus 6, which is the same. Any question? So if you were to run, if you were to rationalize the numerator, you would take complex conjugate, I mean a radical conjugate for the numerator, follow the same procedure, multiply both the numerator and the denominator, so that you don't change the meaning of your expression. Remember, multiplying and dividing by the same thing is like multiplying by 1. You know, 1 is a multiplicative identity. The observation I want to make here is that all the possible radical conjugates are additive inverses of each other. So if you add this guy to this guy, you get the additive identity, which is 0. Okay. Moving on, we have solve by elimination. Solve by elimination. Can someone describe for me the elimination procedure? Solve by elimination. Is it 6? 6. Good. Someone please describe the elimination procedure in general, not necessarily for this system. Just describe elimination procedure in general for any system.
Eliminating one variable.
Okay. So how do you do it? What's the procedure to eliminate one?
Can I try?
Do you just rub it and then say, okay, it's not there anymore now?
No, like first you decide if you're gonna eliminate by addition or subtraction. So if, for example, you say you're gonna eliminate by addition, you find a number that if you multiply, you find two different numbers. If you multiply the different equations, you can find additive inverse of a specific variable.
Yes, yes, that's the perfect explanation. So you're aiming at getting coefficients of the same unknown variable to be additive inverses, so that when you add them, you get a zero coefficient, and that means such an unknown variable will get eliminated from the system. Okay. So which variable do you want us to eliminate here for this system? X and Y are the unknowns. Decide on which one you want to eliminate.
X.
Okay, we want to eliminate X. So how do we eliminate X? We want to eliminate X. How do you go about it? Hello?
Yes, we can like multiply the first equation by 4 and the second one by -1.
Okay, so this is the first equation, second equation. So multiply this guy by 4. 4 times the first equation, what does it give us? It gives us 4x plus 4y, well, that's 24. This is our third equation. Then multiply the second one by -1, so 1 times equation 2 give us -4x minus 4y is -6. That's our fourth equation. What next? Now I have equivalent systems. Remember, these systems will have the same solution as this because they are equivalent equations. So we said that multiplying both sides, the right-hand side and the left-hand side of an equation by a non-zero real number will give you an equivalent system, meaning a system that has the same zeros as that of the original system that you scale. So we expect that a solution to this system will be the same solution to this system, in case there is a solution. Because by now you should know that not all equations have solutions. There are so many equations that do not have solutions. So what's the next step?
Add the two equations.
Okay, now add the two equations, equation 3 plus equation 4. So -4x plus 4x, well, that's 0. 4y minus 4y, that's 0. And then 24 minus 6 is 18. So this is telling me that 0 is equal to 18. 0 is equal to 18. What does that mean? What does that tell you about the system? You wanted to eliminate x. We have failed terribly to eliminate x because when y has disappeared. And we are getting this statement that 0 is equal to 18. What can you conclude about this system? Our goal was to do away with x. It has failed, and not because we have done anything wrong, but it has failed. So what does this tell us?
There's no solution.
There is no solution. This is an inconsistent system. Just say the system is inconsistent. Okay. And by the way, if you are asked to do this kind of problem, not necessarily by elimination, you would have observed from the onset. The first equation is just okay, x plus y is 6. Second equation, 4x plus 4y, you could write that as 4. X plus y is equal to 6. You already know that x plus y is 6. So what this is telling you is that 4 times 6 is 6. which means 24 is 6. This is absurd. It's a contradiction. There's no way any two real numbers can be the same, because if you find any two real numbers which are the same, it must be 1. But if you can prove to me that 2 is 3, then it means there's just one number. All numbers are the same. So this is, when you meet such contradicting statements, such absurd statements, it means the system is inconsistent. Sorry.
Excuse me, sir.
Yes.
What's the difference between a parametric system and an inconsistent system?
Good question. Very good question. So inconsistent system does not have a solution. Inconsistent system has no solution. Now, parametric system has infinitely many solutions. Infinitely many solutions. This is an example of an inconsistent system. So there are no values of y and x you can choose for which this system will be true. It's inconsistent. Let me give you a graphical presentation of these two systems. So the inconsistent one is where you will have maybe one system, the graph is there, and another one has a graph there. And they are parallel lines. They will never meet anywhere. This is for an inconsistent system. When you can represent these graphs as parallel lines, you will never have a solution. Then the parametric one, when you try to graph them, for the first system, that will be the graph. And the second system will also lie on top of that. Okay, you will also override this. So you will have two equations, different equations, with seemingly different equations having the same graph. This will be the parametric system. An example is so easy to formulate for a parametric system. I can obtain one from this system. Just say x plus y is 6 and 4x plus 4y is 24. If you try to solve this, you will find infinitely many solutions. Okay, just a moment. Good. Sorry about that. Do you get the difference now between parametric system and inconsistent system? Of course, there's another third category. This is 1, 2. The third category are systems with unique solutions. And for those ones, if this is a Cartesian plane and there are two unknown variables, then you will have the graph of one, and these are intersecting. So this will be the solution. At this point, all the two equations will be satisfied. Good. Unique solutions. So for any system that can ever exist in the world, it will have a unique solution, or it will be inconsistent, meaning it doesn't have any solution, or it will be parametric, meaning you will have infinitely many solutions. So for parametric systems, choose one value for the unknown and then express the second unknown in terms of the first unknown. Next, we have find all solutions of this. How much time do you have?
Take 3 minutes.
3 minutes.
33.
Ah, 33. That's a lot. 3x squared plus 2x is 0 using quadratic formula. So given x squared plus bx plus c is 0, all know the quadratic formula. X is, because we proved it in class, using completing the square method. Of course, this demands that a must not be 0. You don't want to divide by 0. You are avoiding such kinds of. So what you're doing is to identify these parameters. In this equation, a is 3, b is 2. What's the value of c? What's the value of c in this equation?
0.
C is 0. Good. So x is -2 plus or minus square root 2 squared minus 4 times 3 times 0 divided by 2 times 3. So we get -2 plus or minus. Well, inside the root symbol, this will be 0. This will be 4. Square root of 4 is 2. Divide by 2 times 3, well, that's 6. So you have two solutions. X1 is minus 2/3. X2 is simply 0. So those are the two roots for this guy. -2/3 or 0. And remember, you do not have to use, well, if you are suppose you are not asked to use any method, you could just factorize this and write it as x and 3x plus 2 is 0. And we know these are real numbers. Product of real numbers is 0 if and only if one of them is 0. So either x is 0 or 3x plus 2 is 0. This second system gives you that x is -2/3. Now we have find real numbers. For real numbers a and k, find the domain of this function. And it happens to be a rational function. Is a divided by k minus pi. We all know pi. What's pi? Someone remind us of pi. Or in the Greek, it's p. What is pi? So pi is simply the ratio of the perimeter of a circle, its diameter. This is the circle, the circumference, this is the diameter. Pi is simply this ratio, circumference, diameter. And it's normally approximated to 3.141592653. It goes on and on. Up to now, we've been able to express the values of pi using computers to 13 billion decimal. But it doesn't matter. It's a rational number. Now, in this case, rational functions are only defined when the denominator is not 0. So straight away, k minus pi must not be equal to 0 because you don't want to divide by 0. This means that k must not be equal to pi. So the domain of your function will be the real line except at the point where you have pi, which could be x, so that x is in the real line and x is not equal to pi. So either this formulation or that formulation, it suffices as the domain. Or you could just write in words. The domain is the set of all real numbers different from pi. So for all rational functions, always check. When the denominator is 0, the function will not be defined because we'll be dividing by 0. All rational functions exclude the zeros of the denominator from the real line to get the domain. So here the 0 is pi, therefore we remove pi from this domain. So this function will be defined everywhere except at pi. Then we have this system. That is x squared plus y squared is 4. Is 2x plus 1 is equal to 0. Okay. This is a simultaneous system, which is not linear anymore, because we have quadratics in x and y for the first system. So this is very easy to solve. We could solve for x first from the second equation by saying that 2x is minus 1, therefore x is minus a half. Now that we know x, substitute for x with a half in the first system. So negative a half squared plus y squared is equal to 4. Well, what does this mean? It means y squared is 4 plus a quarter. So LCM is 4. Well, 1 divides 4 4 times, so 4 times 4 is 16. Then 4 divides 4 once, so 1 times 1 is just 1. So this means we get y as plus or minus square root of 17 divided by 2. So this system will be solved by the following two ordered pairs. Either negative a half and negative root of 17 divided by 2, or negative a half and root of 17 divided by 2. Those will be the solutions for this system.
So I'm confused, the part for y squared.
You're confused here. Well, we can do it again. So what I did here, are you okay with x is negative a half?
Yes.
Good. If you're okay with x negative a half, then x squared will be negative a half squared, which is simply a quarter. You know that negative 1 squared is 1. Hello? Hello?
I can hear you.
So you're okay with x squared is a quarter?
Yes.
Good. Now, in that equation, there is x squared plus y squared is equal to 4. We have that x squared is a quarter. So we will have, oh, okay. I've realized, I know now. A quarter plus y squared is 4. So this should have been 4 minus, not plus. Should be minus. This should be minus. So from here, y squared is 4 minus a quarter. This becomes 16 minus 1. So here we will have 15. Are you happy now?
Absolutely.
Good. Thank you for that. Work out the roots of unity. Graph them. Work out the roots of unity. Graph them. Because unity here we're talking about 1. The multiplicative identity. So that question is asking you to solve the system z squared minus 1 is 0, where z is a complex number. Z belongs to the complex plane. Belongs to the complex plane. What's the first thing? So this is your unit circle. 1 is here, so it means the angle is 0. The radius is 1. So we can write 1 as 1 exponent 0. So the first step is usually to write this from rectangular form to trigonometric form or exponential form to I. So that z squared is going to be exponent 0 I. Remember, this z squared minus 1 is 0 means z squared is equal to 1, but I've written 1 as 1 exponent 0 I. By De Moivre's theorem, we know that the roots will be z will be exponent of 0 plus 2k pi divided by 2, because we're finding the two roots, and k runs from 0 up to 1, where 1 is 2 minus 1. So in this case, n is 2. So you stop at n minus 1. 2 minus 1 is 1. So what is the first root? The first root will be when k is 0. So this is at k is 0. Put k is 0 here. You'll have 0 plus 0 divided by 2, that's still 0. So you have exponent 0i, which is just 1. Now at k is 1, you have the second root. So k is 1, meaning you'll have 0 plus 2 pi. When k is 1, this will become 2 pi. So 2 pi plus 0 is 2 pi. And then you have 2 pi divided by 2. That's just pi. So you have exponent pi I, which is going to be cosine of pi plus I sine of pi. This must be -1. Cosine of 180 is -1. Sine of 180 is 0. So the two roots of unity are 1 and -1. You graph them in a unit circle. This is the real part. This is the imaginary part. So this is our first root, 1. This will be our second root, because the angle here is pi. The angle here is 0. So the point is the two roots of unit, -1 and 1. And the only square roots will satisfy this expression. This equation. Any question? Question? No question. And the last bit, find the sum of the following infinite geometric series. Can I have this part? So we have a series which looks like this: 2 plus 2/3 plus 2 9ths, 7, goes on and on forever. We need to find the sum. That's infinitely many terms. We are interested in the sum. Ideas. How do you go about this? First of all, what's a geometric series? What's a geometric series? Or a geometric sequence? Geometric series. Anyone remembers what's a geometric series?
A series in which the ratio of any two successive terms is constant.
Good. The ratio of any two successive terms is constant. You've been told this is a geometric series. First of all, notice that 2 is a common factor. Okay? Simplify this problem, you can factor out the 2. So 2 into 1 plus a third plus 1/9 plus 1/27. Now, to find the sum of these terms, I just need to find the sum of what is inside the bracket, then I'll multiply by 2. Okay? Now, for this series, I need the first term and the common ratio. I know that for an infinite geometric series, the sum should be the first term divided by 1 minus the ratio. So these are the two guys which I need. What is the first term in this series that is inside the bracket?
1.
The first term is 1. Good. And what is the ratio, the common ratio?
A third.
Good. The common ratio is a third. So you take a third divided by 1, or a 9 divided by a third, or a 27 divided by 9, it should be a third. So this sum should be 1 divided by 1 minus a third, which is 1 divided by 2/3, which is going to be 3/2. The inverse of 2/3 is 3/2. So the sum of the series should be 2 times 3/2, because what we have inside is 3/2. So multiply that by 2, the sum of that series should be 3. Use binomial theorem to expand. Use binomial theorem to expand. We need to expand p plus 2r to the 7th. What does the binomial theorem tell us? That this expansion should be summation from k is 0 to 7 of 7 combination k, taking p, 7 minus k, and 2r. Okay, this is what the binomial theorem tells us. Okay, of course, we know that 7 combination k is going to be 7 factorial divided by k factorial times 7 minus k factorial, where factorial is simply you take the positive numbers before the number, multiply them until that number. So for example, you want 4 factorial to be 1 times 2 times 3 times 4, which would be 24. And in your calculator, there's this symbol, there's this exclamation symbol that gives you the factorial. This is the factorial notation. Let's do this. So we have to find the binomial coefficients. I'm going to write out this from the sigma notation. So first at 0, I have 7 combination 0, and then I will have p raised to 7. So when k is 0, 7 minus 0 is just 7. This is 0, so 2 to the 0 is 1. Plus the second term, 7 combination 1, p to the 6, because now k is 1, and then 2r raised to 1, plus 7 combination 2, p raised to 5, 2r raised to plus 7 combination 3 of p to the 4, 2r raised to 3. Should be seeing the trend now. This is sum is 7, 6 plus 1 is 7, 5 plus 2 is 7, 4 plus 3 is 7. So next we have 7 combination 4 is p to the 3, 2r to the 4, plus 7 combination 5 is p squared, 2r or 5. 7 combination 6 is p 2r power 6, and lastly 7 combination 7 2r power 7. We know p to the 0 is going to be 1, so there's no need of writing it. Now all you need to do is to find this guy: 7 combination 0, 7 combination 1, 7 combination 2, 7 combination 3, 4, 5, 6, and 7. And it's very easy to find them. So starting with the first guy, 7 combination 0 is going to be 1. So the first term is p to the 7. So let me show how I got 7 combination 0. 7 combination 0 is simply 7 factorial divided by 0 factorial times 7 minus 0 factorial. We all know 0 factorial is 1. So this is 7 factorial divided by 7 factorial. Any number divided by itself, it's 1. So this first guy is 1. The second guy is going to be 7. So we have 7 times 2. There's a 2 here. So this guy is 7. How is it 7? 7 combination 1 is 7 factorial divided by 1 factorial and 7 minus 1 factorial. This is 7 factorial divided by 6 factorial. You can press this in a calculator, but we all know this is going to be 7 times 6 factorial divided by 6 factorial. So then we get 7. But you can always put this in your calculator. There are those calculators which can also give you this directly. Just say 7 combination 1. It's this key and usually has an n superscript on the left and an r subscript. So then this is 7, but then there's a 2 here. So 7 times 2 is going to be 14. This will be 14 P6 R plus, moving on, 7 combination 2. 7 combination 2. Is there someone who has a calculator to this? 2 factorial. 7 minus 2 factorial.
John.
So this is going to be 7 times 6. That's 5 factorial divided by 2. That's 5 factorial. So 42, that's going to be 21. Now you have 21. And inside here you have 2 squared. So 2 squared is 4. 4 times 21 should be 84. E to the 5 r squared. Plus, how about 7 combination 3?
35.
35. Okay. We have 35 and then there's a 2 cubed, 8. 35 times 8.
280.
So 280 e to the 4 r cubed plus 7 combination 4 should be 280. Not 280, should be 35, huh? 7 combination 4, is it 35?
Yeah, it's 35.
Yeah, 35, and then here we have 2 to the 4, 16. So 35 times 16. 35 times
560.
560. So 560 e to the 4 e to the 5. Wait a minute. This is e to the 4, so this is going to be e to the 3. E cubed plus. Next we have 7 combination 5. Well, 7 combination 5 is the same as 7 combination 2. So that should give you
21.
And then 21, here you have 2 to the 5. So take 32 times 21. So we have p squared of 5. What's 21?
672.
672. And now we have 7 combination 6. That is going to give you 7. And then 2 power 6 is 64. So compute 64 times 7. This should give you 7. So you need 64.
48.
Huh?
448.
448. 448 p add the 6. And lastly, 7 combination 7. We all know that is going to be 1. And 2 to the 7 should be 128. So this should be 128. This is the expansion. Should have. Any question on that? Any question on that? Okay, let's move on to the next. But see, suppose you invested $2 at a compound interest rate of 50% a day. Compute the following. So we have this formula that we need to use. A is P into 1 plus R divided by N, equals to the NT, where P is the principal amount, the amount of money you invested. In this case, P is going to be 2, while R is per period. And then N is number of compounding periods. T is the time. The time in compounding periods. So the time could be days, could be years, could be months, whatever, could be hours and seconds. First problem, you are asked that you should invest this compounding weekly. So the principal is the same, it's 2. Now you need to ask yourself, if you're doing it weekly, so it means your periods are weeks. How many periods will you have? How many periods will you have? After 7 days, you're doing it weekly. How many weeks are there in 7 days? That's the number of periods.
1.
N is 1. Good. And then we need a rate per period. We need the rate per period. We know that our periods are in weeks. Well, the rate that is given there is per day, 50% per day. So you need to convert that into the rate per week. If it's 50% per day, what will be the rate per week? One day you earn 50%. In 1 week, what percentage to be earning?
350.
350%. What else do we need? We need time. We need time, so we need time in weeks. Of course, it's just 1 week. So now we have 1 plus, the rate is 350 out of 100, and it's 1 raised to 1 MT. What does this give you? Well, this is 3.5 plus 1, 4.5, so this should give you 9. Question? 3.5 plus 1 is 4.5. 4.5 times 2 is 9. Any question on this problem? The next one, you are asked hourly. If you're compounding it per hour, so your money is earning after every hour. Second problem, we have, suppose the principal is the amount you invest, it is still 2. We need the number of periods and the rate per period. Now you are investing hourly. So the number of periods should be in hours. So the question is, how many hours are there in 7 days? The compounding period now is in hours. The compounding period in hours. So T will be in hours. What is going to be the time? Well, the time will be in hours. So in 1 day, you know you have 24 hours. How many hours will you have in 1 week?
168.
168. And then, what is the rate now? Per week? Not per week, per hour. What is the rate per hour? What's the rate per hour? We have that the rate is 50% per day. So convert that to per hour. 50. there are 24 hours in one day. So in 1 hour, it will be 50 divided by 2400. And of course, you're doing this twice. So that means you will have the amount as 2 into 1 plus the rate is 50 divided by 2400 raised to 168. Remember, this is the same as 1 plus 50 divided by 100 times 24 raised to 24 times 7. This is if you choose that you will have n, have t as 7 days, n as 24 periods in 1 hour. You're getting the same. So what does this give you? Put this in your calculator. 2 plus 1 plus this fraction raised to about 168. Hello? Compute this guy. So the idea of such a problem is you need to understand how are you doing the compounding, in which period, is your period in years, is it in months, is it in days? Then the rate that you are given, you need to convert it to the compounding period that you're dealing with. And then once you know the compounding period, given the entire duration, you should know how many periods are going to be there. Okay. Use a calculator to find this. Hello.
63.89.
6 what?
63.89.
62.89.
363.
You're getting 62.89 now.
63.
63.
Yes.
Yes.
What does the calculator give you?
53.89.
53.
63.
53.89. Good. Express the second last one. Express the following. 4 decimal places.
I'm getting 63.
Sorry?
I'm getting 63, not 53.
Yes, it's 63. 66. That's, yeah.
63.59. You're asked to express to 4 decimal places, and always read the instructions carefully. Log to base 4 of 1. Express this 4 decimal places. I know so that you cannot access the calculator which compute logs to base 4. So here you need to change the base. Start by letting this to be anything. Let it be t. That is the first step. So t is this guy. Now change to index notation. Change index notation. So what will this guy be in index notation? When you have log of 1 to base 4 is t. How would you change this to index notation? What would you obtain?
Four raised to t is equal to
4 raised to the power t is equal to 1. Okay? At this stage, you should all be seeing T. What is T? When without proceeding, you should all be seeing T. What is T?
0.
It's going to 0. But of course, if you didn't know that, check the logs on both sides. Log of 4, T, log of 1, therefore T times log of 4 is log of 1. I could take any base. I've decided to take base 10. So T is going to be log of 1 divided by log of 4. That's going to be 0. You are asked to write the answer to 4 decimal places. So what will be your final answer? Write this to 4 decimal places. What is 0 written to 4 decimal places?
0.00.
Yeah, just add. Last but not least, determine the 10th term in an AP whose third term is 6 and 8th term is 16. Well, we all know nth term is given by A plus n minus 1D, where n is the number of terms, A is the first term, D is the common difference. So this successive difference between any two terms as we keep going and going in the particular sequence. Now we're being told the third term. The third term. So now n is 3. So if you put n is 3 here, you have a plus 2d. That guy is 6. So put 3 here, I get a plus 2d is 6. And then I have 8th term. 8. So n is 8, put 8 here. A plus 8d should give you 16. We get a system of 2 equations in 2 unknowns. Very easy to solve. Use substitution, use elimination. Could you even use your calculator? There are some calculators which can solve systems.
Why isn't it 7? Supposed to be 7, not 8.
Oh, sorry, 7. 7. So 8 minus 1 should be 7. Okay, how do we solve this system now? Don't need this. We want to solve for A and D. Use any method of your choice. Suppose here I see 5, 10, so D is going to be 2. If I put D is 2 here, and A is also 2. Let me check. So 2 plus 4, 6. 2 plus 14, 16. Good. Those are the first term and the common difference. Use any method of your choice. Now we will ask for the 10th term. The 10th term. So that means n is 10. It's going to be A, which is 2, plus 10 minus 1 times 2. So this is 2 plus 10 minus 1 is 9. 9 times 2 is 18. So this is going to be 2 plus 18. And you get 20. That is going to be the 10th term for that particular arithmetic progression. Any questions? Any question?
Have you sent the answer sheet together with the paper?
The answer sheet for what?
For these questions?
No. For this one, there is no answer sheet. That's why you're in class. It's being recorded. I will send you the recording after this. Okay?
Okay.
Any other question or concern? How much time do we have? left?
It's past time.
Ah, okay.